cloud. So we have bitwise operators and, or, not, exclusive or, bitwise left shift, bitwise right shift, bitwise unsigned right shift, and bitwise undassignment, bitwise or assignment. Assignment because it is having equals to, right? And exclusive or assignment, and bitwise left shift assignment, right shift assignment, bitwise unsigned right shift and assignment. So there are so many things. So if you see the bitwise operators here, and operator, normally ints and units take up to 4 bytes or 32 bits of space, right? That means in Java, ints will take 32 bits. That means it will take 32 bits of space. This means int or uint is stored. That means uint means unsigned. So minus or plus, right? Minus is something which is signed integer, whereas uint is something that is not that is not signed. That means it will be a plus number. So normally, if you say 2 power 32 bits, 2 power 32 means like 2 power 31 minus 2 power 31 2 plus 2 power 31 minus 1 is a limit for the integer. So for the sake of the tutorial, we figured that ints and units only take 1 byte. That is 4 bits. Have 8 digit. That means 1 byte is nothing but 8 bits. So what he's trying to do is here, he's representing 37 and 23, and is doing a AND operation between 37 and 23. So when you represent a 37 into a binary mode, it will become like this: 0 0 1 0 0 1 0 1, right? So what he's saying is, if it is 1 1, AND operation will give you a result of yes. That means it will become 1. If 0 and 1, it will become no. That means 0. 1 1 again 0. I mean 1. 0 0 becomes 0. 0 1 becomes 0. 0 1 becomes 0. 0 0 becomes 0. Notice how each binary digit of 37 and 23 are compared. Result as 1 wherever both 37 and 23 had 1, and result as 0 otherwise. So whereas regular AND operation, right? Regular AND operation, what happens is, when we compare two booleans, we normally do boolean and boolean. The expression is only true if both booleans are true. In the same way, integer is equivalent in case of bitwise operations. So this one represents a boolean. If this is the 0 is equivalent to integer value 0. If it is false, that means 0. True means 1. So that's how you represent. So electronics, basically when you switch off, right, there is a button to switch on the light. So you switch on the light, it becomes 1. That means it is sending the signal to the bulb. If it is 0, it will switch off. The computers works similarly because they're electronics too. So as the AND operator only outputs 1 when both the binary digits are equal to 1. So now you have operator truth table, digital 0001 to 0101, and you have the result triple zeros and 1. So you can do the same programming here, like if you do, you're generating random integer and you're trying to find using AND operation 1. When converting base 10, rightmost bit represents 2 power 0, that is 1. So when the rightmost bit is 1, we know that our number is odd, or we are adding 1, so bunch of powers to 0, which always be even. So the rightmost bit is 0, we know our number will be even, right? So since it consists of adding up a bunch of even numbers, here is the example. So we are trying to find using AND operator. So if I given a number, if you try to add 1, right? If you try to add 1, and is nothing but kind of adding, basically. You're trying to do AND operation with 1, that means 0, 0, 0, 0, 1, then 1, 1 will become 1. If there is a 0, that will become 0. So what does that mean is like either you convert see 37 you represent into 0, 0, 1, 0, 0, 1, 0, 1, right? Now if I add 1 to 37, what it becomes is this becomes 1, but all of them become 0. So it will become 1. That means 37 and 1 will become, you can easily say 37 is a odd number. If in case of even number, right? In case of even number, the last value of the bit representation will become 0. Then you add 1, right? 1 and 0 become 0, right? All the other numbers are 0, so total number becomes 0. Then you can easily say this is odd or even. It's very easy to say, wow, it's really awesome, right? So what I'm trying to do is, I take bitwise. This is really awesome. So bitwise operations, right? Bitwise operations. Right now, okay, I'm not taking public static void. Right? So I'll take this random thing, math.random. Copy. Let's put here, but right now, first for the example purpose, what I do, int a equal to int number, num equal to 37. By looking at it, can you tell whether this is an odd number or even number? Rizwan?
Yes, sir.
Is this an odd number or even number?
It's an odd number.
Odd number, right?
Yes, sir.
So int num equal to 20. What is this?
This is even number.
Even number. If I want to find out, right? If I want to find out a given number is odd or integer, odd or even, right? So what they're saying is you take if condition and do AND operation, right? So let's get the result here. So when you do int result num 1 num 1 and 1, it's result 1, result 2. Let's print. This is num2. This is num2. If somebody asks you to find out given number is integer, I mean given number is it even or odd, you can easily find out this way. So result 1, right? Equal to 0, right? This means
the number is even.
good. Means otherwise
It's odd.
So yesterday we learned this operator, right? This is called what operator? The question mark colon.
Question mark.
So if you put question mark here, if this results becomes true, it's true, else it becomes odd. So we will also print result 1 and result 2. First result is 1. Second result is
2. Oh, it's the same result is even.
So 20 is even, odd
Uh-huh.
is. So what's going on is, let's print this one too,
Mhm.
right?
Mm. No, there is an error on line 25.
Line 25.
Uh-huh. Oh, you forgot the semicolon. Yeah.
So this is a representation.
Oh, integer to binary.
So this is representation for 20.
20. Okay, that's a
Right?
binary representation. Yep.
Yeah. If you go here, is there a way how to go to board? I'll type this one here. Yes, you can do it here, right? So what he's saying is, I'm going to take this number and then plus, and means like what?
And
Right?
means true.
So
Yeah.
one representation will be like this: 0, 0, 0,
Uh-huh.
1. If you see the results, 1, 1 becomes 1, 0,
Mm-hmm.
0 becomes 0, 0, 0 becomes 0, right? 1, 0
Mm-hmm.
becomes 0, 0, 0 becomes 0, 0, 0 becomes 0, 1, 0 becomes 0, 0, 0
Mm-hmm.
becomes 0, and the total value will be equal to 1.
1.
So that's the reason we are saying this is odd number. Okay, if I do the same thing, if I do the same thing here, 1, 0, 0, 0, right? Now I'll remove 1. So I'm adding 1 to this. So what happens? 1, 0,
0.
0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0,
0.
equal to
0.
0. This
Mm.
is,
Odd number.
tell me what is this when it becomes 0?
This is a odd number.
No, 1 is odd number.
Okay. Yeah. Okay. If it's 0.
37, when you add 37 is odd number, 20 is even. So when you add 1 to the binary representation of 37, the result will be 1. So when you add the binary representation of 20 to binary representation of 1, the result becomes 0. That's why this is called even number.
Okay. Okay. Question, sir.
Mhm.
So, like, do we always have to use the binary representation of 1 with the actual number?
No, this is one logic they said how you can use AND operator to find out whether given number is an odd number or an even number.
Okay.
Okay.
Okay. Like for example, like the binary representation of 37. If I like use it with a different like of number 2. Okay.
Yeah.
Is it still gonna work? Is it still gonna be the same? Like the result, like is it still gonna show like it's an odd number or it's an even number?
Or if you do binary result of 2, no.
Yeah. No, it's not.
You may
Okay.
get a different results.
Yeah.
Right? See, if I ask you to find out whether given number is even or not, right? What
Mm-hmm.
I'm gonna do is like number mod 2
Mm-hmm.
equal to 0. Right? Number 2 dot if not equal to 0 means given number is odd.
Odd number.
Let's execute this one. That is also easiest way. See, if you don't know binary operations, right?
Mm-hmm.
Then this is how you find it. So number 1 is odd, 37. Number
Mm-hmm.
2 is odd this way.
Mm-hmm.
Got it?
Yep. I got it.
Now the operator. What is the difference between or? Or operator is like opposite to 1. When it is 0 and 0, 0, 0 and 1, 1,
One.
0, 0, 1, 1, 1, 1.
Mm-hmm.
Right? So let's take a look at some example before, except now operator instead of and operator. We are doing 37, 23 will become 55.
Mm-hmm.
How it will become 55? The representation is 8 bits, right? 3 plus 5, 8 bits. This is how you get it. How you get it? We used to do this one, right? What we used to do is that and date, draw something, draw something. Let me text two. Okay. How we used to do is if I want to find out like this. You remember this one? Have you heard
Yep.
of?
That's the binary conversion, right?
Yeah.
Yeah. Yeah, I know that. You can use the pen instead, sir. The pen right here.
Where's the pen here?
Yep, that one right there. You can use that instead. Mm-hmm.
Yeah. And then this becomes 10.
Mm-hmm.
Right?
It's with zero.
0,
Zero remainder, yep.
2 becomes
5.
5. This
0.
becomes 0,
Uh-huh.
2,
2.
okay, 2,
Mm-hmm. With 1.
1. Now it becomes 2.
1 0.
So 20, the value is
1 0 1 0 0.
0.
Mm-hmm.
So now we start with multiplying 2. This is 2 power 0, 2, 2 square,
2
2
cube.
3, and 2 power 4. Right? So 16
Plus 4.
plus 0
Plus 4.
plus 4
Plus 0, 0.
plus 0 plus 0 will be 20. Right?
Yep.
This is what I was trying to show yesterday. I'm going to close this. This is a binary representation converting back. Now, let's keep it paint. Okay. Now we have AND operation we have seen, right? Now 37, 37, when you represent, the value becomes 55 because 0 and 0 becomes 0.
0.
Here we have 1 and 1 becomes 1, 0 and 1 becomes 1, 1 and 1 becomes 1, 0 and 0 becomes 1, 0 and 1 becomes 1, 0 and 1 becomes 1, 0, 0 becomes 0, zeros becomes 0, right? That's what it is. So sometimes people ask in the interviews, or not in the interviews, exams, basically, to give the results. What is the value of given 20 and 23, 20 or 23? Can you give me the output? You should be able to convert the number, and then you provide an output based on this. Okay, that's why I'm giving this. This is one point definitely in a Java certification exam. Okay, so you're saying yes, it's buttons. Yes, sometimes the people are saying, see, show pop-up. So in real time, they might be using these operators to find out whether this is yes or no, okay, or cancel, something like that. So buttons and yes, button, buttons and no, no button. Let's look at the possible situation. We are building a pop-up window. The bottom of it, we can have yes or no, okay, cancel, but any combination of those. How should we do this? Here is the hard way, right? What we do normally, if we send all the buttons and we say true for one value. But if you understand how to use bitwise operators, it's easy to say whether it's S or you know something else. So you're going to pass the value and do AND operation. It becomes true, right? 4 and 4 becomes true. 3 and 4 becomes fail, right? Let us do this. Let a simple example, right? Let us do simple example. Find out. Maybe we can do it here. Simple example. I have int 1 equal to int s equal to 1, right? Int no equal to 2. Int okay equal to 4 and cancel to 8. So you have to set all the other booleans to false in this case, because this method will be taking multiple parameters. You remember, like we talked about object-oriented programming, we always can pass the reference without sending all the properties. So in this method, he's only sending one property, and he knows how to use bitwise operators. So if bitwise operator of, right, bitwise operator of yes and buttons is integer, right? So if I send 1 and yes, let's see what happens.
Yeah, and you forgot the semicolon on in cancel.
No, we have, oh wait, thank you. Right here, if you put 2, right? We'll see what happens. It becoming 0 because s value is 1. With 2 it's becoming 0. Let's see. Okay, this should fail too. 0. So that means same number plus same number becomes 0 and operation, but different number will become false. So if you learn how to use this one, maybe explore something and get familiar with it, then you become really expert. Then it will be easy for you to program with it. So now not operator means if there's a 1, if you say not of 1, it becomes 0. If there is 0, if we say not of 0, it becomes 1. Right? 37 is this one. Minus 37 will be with 1. So you can see the result here. Like 37, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. What happened? Not become, everything became a 0 became 1 and 1 became 0. So these two zeros became 1, 1. This 1 became 0. This 0 became 1. This 0 became 1. And 1 became 0. And 0 became 1. 1 became 0. So that's how it will work. So all trues will become false and all false become true. Now we are getting into an important topic of 2's complement. What is 2's complement is? So we've seen now the signature, right? Now, if you see the number, you are seeing the signs of minus or plus. So the 2's complement, u int and int. Now fun begins. We are taking closer look. Unsigned integer, 4 bytes or 32 bits long. We mean 32 binary digits. It is easy to understand. To get this base 10 value, we simply convert the number to base 10 regularly. We'll always get the positive number, right? Unsigned integer. So integer value also uses 32 bits, but it will store negative bits. So this is nothing but a negative bit, right? Because it is in a negative. But what happens is, when you convert a binary number, it will become a binary decimal always. But a negative integer, right? A negative integer, integer means it can have positive or negative. Also uses 32 bits. But when it is negative, you have to get a negative binary number, not the positive number. So what he is going to do is, he will take the binary values of that particular negative number. The first digit is used to store this sign. So you are on the right path. So let's take a look at 2's complement system for storing the binary numbers. If there is a negative number, then you need to store that as a 2's complement system, like using 2's complement, because it makes binary arithmetic easy. Why we are using 2's complement, you can YouTube and we can discuss tomorrow. So right now, 2's complement of binary number, we simply flip all the bits, do what the not operator is doing. So what the not operator is doing here, it is changing all the zeros to 1 and all the 1s to 0. That is what the not operator is doing. So 2's complement is doing the same thing here. So he's taking 37, flip all the bits, 0 became 1, 0 became 1, 1 became 0, 0 became 1, 0 became 1, 1 became 0, 0 became 1. So now this is flipping. After that, is adding 1 to this one. If flipping all the bits and then adding plus 1 to it will give you 2's complement number. Then the result becomes this one. Okay, so let us print the value of, right? So let's print 37, right? We'll print here. We'll take not symbol, not of 37. Right? This is 37, and this is, let's put and. What is the and symbol will do? Minus 37 plus 37 should become 0. See, it became 0, right? So let's print the binary representation of 37. We have that this thing. Okay, so now we have the positive binary representation and negative binary representation. Let's check what is the value we get. Minus 37. See, minus or not becoming this way, right? So when you do plus 37 minus 37, what happens? Becomes 0, right? Plus 37 minus 37 becomes 0. And then this one also became 0. So AND operation is doing the same thing. So it is trying to check bitwise operation between each and, but this is a decimal operation, this is a bitwise operation. Okay. So when it say bitwise operation, it will convert this 37. So when you print, right, this one, it is like this. Minus will be like this. And then this is the minus value. So because of this, we need to up prefix zeros. Zero and one, zero, 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 zero. until here, and then 0, 0, 0, 0, 0. And 1, right?
Yes, sir.
Why it is 1?
Because it's AND value.
So they're doing AND value. Because of that, we have left 1 here. So for that reason, what this said was, when you're doing some operations on these negative numbers, store the particular number in a 2's complement. That means what they're saying is 2's complement is nothing but, I will tell you what is 2's complement. 2's complement equal to, this is a negative representation, this is positive representation of 37, right? This is 37, this is minus 37, this is minus 37. 2's complement of this is, you need to add 1 to it. When you add 1 to it, you get 2's complement. So this is positive representation, this is negative representation. But when you're doing arithmetic operations for minus, you always add +1 to generate 2's complement. Now 1 0 becomes 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0,
1.
right? This is the 2's complement. Now if I do AND operation between positive and 2's complement, what it becomes?
Same, 1.
0 0 0 0 0 0, but it has to become, no, something wrong here. Okay, add 1. If you, this is plus 37, and then flip, you need to flip everything.
It's on 2's complement.
So, okay, this is a positive 37. Maybe I'm taking the wrong number. When I print it, what do we get? Positive, this one, 37, right? We take this one. So he said first to minus, first flip it, 0 1 1 0 1 0, right? Now let us add 1 to it. Becomes, add 1. Add 1 means +1, not and 1. Okay, so let's add 1. And when you're adding, we always start from here. 1 1 0, and then 1, and then 1, and then 0. This is 2's complement, I think.
No.
No?
Yeah, because like it's showing the example saying only the first stage right here, the 0,
Okay,
the first one
because
on the right.
we need to represent in 8 bits, I think. This one is how many?
Yeah.
1,
So
3.
yeah, like yeah, what I was thinking is like on line 25 when we are printing, instead of integer to binary, can we do like byte to binary representation in the program itself on line 25 up there? Yeah, like when we did integer to binary, right? So
Yeah,
instead of integer, can we use like byte to binary system? No, byte to binary. Yeah.
there is no
To
byte.
byte. Oh, okay. I see.
Integer,
To string to binary.
Okay. Let us follow his example so that we can find out. So this is a starting value 37. This will be
Yes.
the 10010. Right? 100 and he's adding 2 digits before that. He's adding 2 digits before that. So we flip it 11011010, right? When you flip it, now we need to add 1 to call this as a 2's complement. So will be 2's complement of minus 37 will be what?
0.
1. This becomes 1. This becomes 1. This becomes 0. This becomes 1. This becomes 1. Becomes 0. This becomes 1. It becomes 1. Did we match this number? 11011011. 11011011. Correct. This is the 2's complement. Okay, if somebody asks you what is 2's complement,
It's like
you find the binary number and flip all the digits right into
like from true
the
to
opposite,
false.
and then add a
1.
+1 to it, then it will become 2's complement. Then you do the arithmetic operator. So when you're doing plus 37 and minus 37 means first convert plus 37 and find 2's complement for minus 37 and apply AND operator. Got it? So first you are finding minus 37 value, then now you are finding 2's complement. This is the 2's complement here. Now when you do 2's complement, now take a look at it. We all know that this should equals, but when we add 37 to its 2's complement, what we get is this one. So we're adding plus. So 1 becomes 10. So 1 comes here. 1 becomes 1 1 comes here. How it will work? So this is what we are getting here. This is becoming plus 0 0 0 0. How to add two binaries? Binary addition. By binary addition calculator, let us see. 1 plus 1. This has to be 1 plus 1. Binary values 10. Decimal values 2. That is the reason. So if you see this, if you see the link here, 1 plus 1 becomes 10, right? So the binary operators, again, we have plus, and we can still use binary, regular arithmetic operators in binary. So when you say plus, this is becoming plus operation. So now we are adding 1 plus 1 In binary, I'll put right, 1 plus 1 becomes 10. So that means what happens when 10, we'll put we'll put 1 here, and then it becomes 10. Now I come down here, I put 0 again, because 1 plus 1 is 10. So 1 plus 1 is 10, so I put 1 here. 0 and 1 becomes 1, right? So this is 1 plus 1, right? Becoming 10, so I put 1 here. Now it becoming 1 plus 1 plus 0 is 1 plus 1 in binary is 1, 10. So the 1 goes here, the carrier will go here. Now 1 plus 0 becomes 1. Now you have 1 and 0, so it becomes 1. Right, now you have 1 and 0, it becomes 1. Now 0 becomes 0. And then 0 and 1, 1. 0 and 1. Let's get the results here. Am I doing right? This is 0. When it becomes 0, we get this one. Let's use the calculator. I'm doing something wrong here. I get here, I come to here. Binary value. So we all know that it should equal to 0 when we add 37 to. So it's 2's complement, that's what we get. So when you do the 2's complement, we're getting 1, 1, 0, 1, 1, 0, 1, 1. So we are taking this one and adding this to this one. So 1, 1 becomes 10. So put 1 here, 0 here. Right? So now you have 1, 1. 1 is here, so you put 1 here and 0 here. 1, 1 becomes 10. You put 1 here, 0 here. Now 1, 1 becomes 10. Put 1 here, 0 here, 1 here. 1, 1 becomes 1 again. So I think what I did is wrong here. Let me take a MS Paint so that it will be easy. So 0, 0, 1, 0, 0, 1, 0, 1. So 2's complement of 37 minus 37 is 1, 1, 0, 1, 1, 0, 1, 1. So we know that binary addition 1 plus 1 becomes 10. So you put 1, 0 here. 1 plus 1, 0 here. So there is 1, there is 1. So it will become 1, 0 again. This one becomes 10. So put 0 again. This one becomes 10. Put 0 again. This one becomes 10. Put 0 again. This one becomes 10. Put 1 again. This one becomes 10. So this is the value, we got it. So the meaning of this one is what? Notice that since our integer hold 8 binary digits, 1 is our result that is dropped. So we are holding only up to 8. That's the reason we are dropping this one. So, and we end up with 0 as we should. So the result is 0. So to do arithmetic negative operation, what we are supposed to do is you find a 2's complement of the negative number and then you calculate you do addition on those numbers so that you'll find the actual result, right? So the shortcut is saying like first flip it and then plus 1, so that when you do plus 1, that means like 1 1 becoming 0, I mean 10. So 1 0 becomes 1, but 1 1 becomes 10 in binary number operation. That's why. So this is exclusive OR. We can see that tomorrow. But in between, I think I'll give this link to you guys. Okay, I'll give this link. I'll also prepare. Come on, where is chat? I'm not able to send it. I'll give it on WhatsApp. It's very interesting. I mean, see, even though it's taking time, I'm very excited to learn this. Okay. Were you able to understand, Rizwan?
Like the binary conversion, the 2's complement and all those things.
Yeah.